Well, hi, good morning, and thank you so much for joining me here in my shop. Oh, what happened? What happened here? A cat stepped on my keyboard. Okay, we're still operating. Off to a good start this morning. So, hey, if you've been watching my videos as I've been posting them, thank you very much. You know I've been working on a tube tester, and it hasn't really gone as well as I would have wanted, and it's not on my bench now. So I've just set it aside in favor of doing something I might enjoy a little more, because I kind of saw enough of that tube tester. So it'll come back, but for now we're going to start working on a radio. And I thought I'd let you watch my bench buddy here. This is Wally. Usually it's Bert who's up on my bench, the two brother cats that I have. You can tell them apart very easily. Wally, show them your back. Show them your back. See the white patch? Wally, white, has a patch. Bert has no patch on his back. Otherwise they look pretty similar cats. And I think he's getting tired of it. So, and what are we actually going to work on? This is the radio we're going to work on here. So I purchased this radio off of Kijiji for $50 about 3 or 4 years ago. And I've just had it sitting and waiting for a chance to come in here. Now it has its chance. Had I known a little more about this radio, I probably wouldn't have purchased it because it has no speaker. The speaker you see on the bench is a spare one that I have that maybe I can make work in this radio, maybe. So we're going to take a close look at the radio itself. I'm going to get it out of the cabinet up on the bench. We'll check it out, and we'll see where we're going. But personally, I think this is a really great looking radio. It's a commanding looking radio. Looks like a I don't know what to call it. What's it look like? Looks like an old radio. That's what it looks like. Okay, great. There goes the kitty. And here we go. Okay, we'll take a closer look at the radio here. Both my cats are in here now, running around. You can hear a funny little sound. That's one of the cats in the back of this radio now, poking around with stuff, so he's ahead of us. So, a couple things. Pretty dusty, because it's been sitting in one spot. Cobwebs all through here. Other than that, can you see this dark area here and here? You see the same thing here and here. And that's just finger marks from somebody doing this a lot. Which one's the tuning? So this is probably the band switch. This is tuning. Where's the pointer? Oh my God, there's no pointer. Uh-oh. Okay, and this is probably tone. I'll be holding this on. Yeah. Maybe these aren't the right knobs. And this will be the on-off. Okay. The knobs are all the same type. That's kind of good. You know, just on a basic attractiveness, this radio is quite attractive. The interesting wood shape, interesting wood details in it, going up here. So it's a nice cabinet, no doubt about it. I wonder if there's almost as much work in the cabinet as there is in building the radio itself. So, talking about the radio, I'm surrounded by cats. Oh my God. You know, I tell you, if I didn't have these cats, these new cats here, my wife and I, we would not be as healthy as we are, given what's happening in the world right now, for sure. Where is he going? Where'd his brother go? Oh! There they are. I know lots of you like watching the cats, so I'm not afraid to put them on the screen here. Okay, that's enough. That's enough though. So getting back to the radio once again, if we look at how many bands are on it, there's five bands on it. Broadcast band at the bottom. Next band up here is a shortwave band that covers a large range of frequencies. In fact, basically all the broadcast frequencies that would commonly be used can be found in here. There'll be some difficulties with tuning here because a little turn makes a big difference. So to compensate for that problem with this kind of shortwave band, it has 3 more bands. These are called band spread bands. And what they've done, like this one here that says 9.6, 9.65, 9.7, that's a little tiny piece of this band down here, spread out, spread band. Same thing around 11 megahertz and the same thing around 15 megahertz. The bands are denoted by their wavelength, or the average or rough wavelength. There's no end to it here. What are you chewing on? Don't, like, there's a lot of wires in here to chew on, so I'm a little worried when they're... Oh, just a little worried. So this radio kind of has an interesting feature in that you can very quickly and easily tune these band spread bands and find if there's something there. This one is a little more tricky. You have to be a little more careful tuning along, or you go right past the stations and that. So, but in any case, a typical, very, very typical radio out of the, I would say, 1940s. Somebody stuck this on the front, Philco, using these stickers. It's very disappointing to me. There's 2 reasons for doing this. One is they wanted the word Philco to show up. The other one is the thing has been refinished and the original writing is gone, and somebody wanted to put it back, so they went and bought these sticker letters and stuck them on there, which is really unfortunate to me. Has this been refinished? Well, I don't know. What do you think, God? What do you think? Oh, so okay, he's going to check it out closely now. But what do you think? Has this been refinished? How would we know? So if somebody did a really good job on refinishing, I don't think I'd know. This is just a crazy. Oh, whoa. Uh-oh. Uh-oh, going high, going high. So cats go through a period. Actually, my wife and I were watching a video about cats, as if we need to. And they pointed out that cats have a cycle in which their activity goes from very low to up, 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 and then there's a period where they're literally frenetic. And this is what we're witnessing with these cats. They're kind of becoming frenetic right now. They just seem to have this pressure to do something. I've got to do something. Oh my God, what could he do back there? He could do a lot of stuff back there. So you're getting a good look at my shop here, which I don't normally show off my shop like this, but yeah, there he goes. Those are my grandparents there, by the way. One set of my grandparents. Well, he's doing the Rin Tin Tin thing now. Okay. Okay. So if you watch my videos, you know from time to time I get extracted. Yeah, I get extracted, all right. I get distracted. I get extracted. Okay, so it has a bunch of push buttons here. A lot of them. Oh, that was good. 1, 2, 3, 4, 5, 6 push buttons in the radio. That's quite a few, and these are almost certainly for the broadcast band only. And they've got some words in here. Let's take a little bit of a closer look at that. Oh, not that. Come on, focus in. Well, so if there were, oh yeah, there's some words there. CKO something or other. This can give a hint as to where the radio came from. That says Chum, C-H-U-M. Chum was the big AM station. CFGM, I'm not sure that station exists anymore. CFOR, that's what that is. Somebody's penciled it in. Some of these are penciled in. In fact, all these are penciled in. Except for the last one. The last one says dial. So you want to get off the push button, so you push this button, the dial button, and then the dial operates. And that's this guy up here with no pointer. No pointer, no speaker. Maybe this wasn't the best radio to buy. Okay. But $50, not a big deal. Let's turn it around and we'll look in the back here. It's definitely heavy. One thing about these old radios, these beautiful, beautiful cabinets that they are as rugged as can be. That's why these cabinets are still around and still solid. They are really, really well built. Okay. Don't know if I've ever had one that was really flimsy. So first thing my eye catches is this interesting little piece here. This metal piece. So, I mean, you can guess this is some attempt at an antenna. Here's the dial string, here's the pointer. I found the dial string and the pointer. Caught on something there. All tangled up in these wires. Oh, what a mess. Did you do that? The helpers come again. Don't bend it. No, don't bend the pointer. That pointer's bent. I don't think he did it. Okay, let's look inside here. They just love the wires. Okay, maybe we can get a little more light on the subject here too. What do we got down here? I'm coming down, buddy. Oh, he's taking off. Okay, let me just look up at my monitor for a moment. Yeah, good. So what do we got here? So all the tubes are here. This one looks like a replacement. This tube is a 78E or 78. These are old tubes. These are. It looks like this is 827. I don't know what that is. What is that? I wouldn't normally pull any tubes out, but ooh, 8K 8. I don't know what that is. This is a rectifier tube, though. I'm sure you see the two rectifiers. Number 80. That's a number 80. That's what that is. So again, that really pegs this as a pretty old radio. Philco has a phono input. I didn't see any phono button. Has a sheet under it. It's not asbestos. Held in with these screws here. Up at the top. I can't quite see. We need better light here. So what I'm interested in is how is this held in right now. So obviously there's these two screws. Feels like there's another one up here. Maybe not. Yeah, there's something up here. Don't know what that is. Maybe it's just a screw driven down into wood, is I think what it is. So everything seems intact. There's only one IF can up here. Capacitor works. Good show. And these are all the tuning adjustments for the push buttons on the front. Information stuck inside. There's a sticker here, but I think this is the license warning. That if you use this radio without a license, you might have to forfeit it to His Majesty. That's what it will say. Okay, so sorry it's a bit of a dark image there. And I'm going to get that out, stick it on my bench. We'll take a good close look at it. Okay, here comes the radio here. Okay, let's make some more observations. So, what's going on with this? It's so badly stained. There's stain going up here. There's all this stuff here. There's some dark thing here. So this looks like a material. It looks like it was sprayed on. Looks like it was sprayed on before these buttons were installed. So I guess they must have, here you can see a little bit of it kind of running down here a touch. So some kind of a backing, might have been black maybe at the start, or I don't know, but certainly the inconsistency of it is really a downer for sure. There's piles of dirt and dead spiders in here. This is really not in good shape. So when I bought this radio, it was in someone's house, but clearly before it was in their house, it was, who knows, somewhere horrible. Yeah, it's not in very good shape. Two lights out here. Here's the tuning wheel minus the string. Here's something quite surprising. How many radios have this? Here's the pointer. No, wait, there's two pointers. There's two radio pointers here. What is happening? What is happening here? So, seeing two pointers here, what is this happening right here? So where is it just twisted together? What does that tell you? There's two pointers. There isn't two pointers. Somebody has brought another pointer. Why? Why would they do that? They lost sight of the one that was originally there. Neither of these are the original. Is that what it is? Neither of them. I don't think so. This string that I'm having trouble untangling is caught down here. So this is almost certainly the original string. And which pointer does it go to? Tell me it goes to this one. This big ugly thing here. The string has been heavily glued in here. That's all this junk. Ugh. Well, this looks like some handmade, homemade version of a pointer. It does have a little dip of white paint on it, which makes it look... Man, that come out of a factory? I'm just going to end up cutting the string because it's not going to do any good anyway. Okay. How's this pointer go? Would work. It's not long enough though, is it? This isn't long enough. Well, how can we tell? Yeah, probably is long enough. It just clears this bracket. That's suspicious. Now how about the other one? Yeah, radios come with a choice of pointers. So this one, this is definitely like from a radio. The string is like that. Let's try this one out. First of all, it sticks out way too far. It's long enough, it's practically reaching these buttons. And it would interfere with this bracket if it came over this far. I don't think this is the right pointer. I think this one is. Right enough, anyway. This is right enough. You gotta wonder what the story is. You know, this radio's been around almost as long as me. Actually, it's been around longer than me. I got a story. It must have a story too. Okay, that's the pointer story. Let's get the string out of here. I'm going to cut this. I don't know what it's caught on, so I'm not going to yank it. We just put that over there. Okay, put these screws in the bucket. Are these the right tubes? Are these tubes in the right place? What's this piece of wood laying here? The answer is probably these are the right tubes, but not necessarily. So this is some kind of wood block that was glued in place to provide support inside the cabinet, and it's fallen out onto the radio. So don't worry about that. Okay, what about the general condition up here? Let's get the other camera going again. General condition of things. So there's a coil up in here. And, so much dust. Wow. another coil right here. Just looking for any obvious gross damage that may have happened. The sounds you're hearing are my cats playing in the laundry room next to me. In case you're hearing thumping and stuff, and that kind of sound. Okay, so here we are looking at the interesting arrangement up here. Resistor, capacitor, straight to the grid of the first tube here, and capacitor plates look fine. Yeah, nothing's bent or smashed up. What can happen with these plates? Pretty easy. People don't know what they're doing. They reach in the dark, and next thing you know, they've bent the outside plates one way or another, usually inward, and then they start scratching. So we see the big wheel. There's a string route now. The big wheel, pulley here, pulley here. So exactly how the string goes on here, we need a string diagram to know. Guesswork. As simple as this might look, guessing not recommended. Here's all the tuning capacitors here, and what else might we see up here? That's some kind of interest. Not too much. Okay, let's go look underneath. We'll see what we got here. Oh, there's a couple more things. Wires hanging out, cable hanging out. So this is the speaker cable. 3 wires. Is that right? Yes, 3 wires, and they're in fairly good shape. Yeah, I think they're in pretty good shape. You see the style of the plug here. This pretty much matches the plug that's on the speaker I have, but the speaker I have is for a General Electric radio, and this is a Philco radio. There's no reason to think you could just plug one to the other, and there's some serious issues with doing this. This radio uses I'm pretty sure it uses a field coil as part of its power supply filter system, which was very common back then, and that's why this has got three wires. And so the speaker is critical in the operation of the radio, much more than you might imagine if you don't know about these things. 78. That's a 6J5. Ooh, I don't know if I have any of those. This is probably a 6SA7. I don't know what it is. This was the 80. And this must be the output tube. I'm going to take a look at what it is here. Yeah, those are cats smashing away in there. This is probably a 6K6 or 6V6 or 6F6. 6F6 is what it is. Okay, all common, pretty common tubes. If you look down here through the holes, you see some screws. Those are all adjustments for probably trimmer capacitors underneath. What's that piece of lumber in there? What's that? Just a flake of junk. Okay, once again, time to look underneath. Oh, these 2 wires coming out. Oh, more wires coming out. So this has got to be antenna and, whoops, down here. Antenna and ground leads coming out. Which is which? We can look inside and figure it out. And these are in good shape. And then we have the wire coming out of here, heading up to the light. This wire is going to short. It's going to develop a short right here. It's a very serious problem. This short would be applied right to the power supply transformer, and it may be insufficient to pop your house fuse. This short here you could end up losing the power transformer, and it would be ugly. It would be ugly because things would get really hot. I mean, you'd have a fire or something like that. Plus, this would spark a lot. So, I mean, if you shook the radio a little bit, some wild stuff would happen. How's the other one? The other one's the same condition. Got it. So those got to go because they're dangerous for this radio the way they are. And look at the power supply cord itself. Okay, first of all on the far end, let me just grab the far end here. Somebody's cut it off. So they've cut off the power cord. Nice and flexible up here. No it isn't. No it isn't. No. It's cracking to pieces. Feels nice, but as soon as you bend it, the cracks just open right up on it. Huh. Copper everywhere. Damaged here, and then right here, just where you would expect. Yeah, it's another. This is even more dangerous. So you could blow the nuclear power plant with this guy. Holy smokes! Fireworks. Okay, so there's a number of things that have to be dealt with before we try plugging this in. And I didn't say it. It is my intention to try to get this operating today, but I'm not sure I'm going to get there. Here they come again. Oh my gosh! You didn't quite complete the jump there. There you go. See what happens? They walk across my keyboard and my videos go crazy. Helpful guys they are. You know, his brother's down there doing something. They do travel in a pack of two. Twice the fun, twice the trouble. Isn't that right, Bert? Here's Bert. I got Bert. I got him under control now. Such nice cats. So we went with the theory that orange cats are nicer cats. Most orange cats are male cats. And our experience, we've had orange cat, our last cat, orange cat Peanut, was a wonderful cat. These two guys seem great. I mean, we're having a lot of fun with them. Yeah, they're just cats doing their thing, but still. Okay, so tipping this thing. Heavy weight here, nice flat side there. We'll just pull this light off. And what good is this wire? This wire's no good. Just cut it away. Fix that up later. We can tip it this way quite securely. There's this piece sticking out here. And you have to put blocks under it. Let's see what happens. How stable is it? I don't want this tube getting smashed up. Very stable. Even with this thing here. Okay, we look underneath. Hey, I think somebody's done some work in here. Let's get that big ugly spider web out of there. First and foremost, is there a gold bar hidden in here? No. Okay, we missed the gold bar opportunity once again. I'm just going to cut this power cord off because it's just not doing any good. Goodbye to that. Yeah, it's definitely somebody's done work in here. So what I notice is this guy here. I can come up a little bit closer. We can really see what was done. So this is a filter capacitor, and so is this guy. These have been added, and this one almost certainly added also. So we see this one. He used the existing wire here, brought the negative around to this terminal, and so this capacitor has a support strap, and he managed to solder it in down here. So he managed to jam that in there and get it solid. It looks very risky to me. It looks like the let me get a better pointer. This bracket, which is soldered to the chassis, is practically in contact. Well, you know what? It doesn't matter. This is a ground terminal anyway. It doesn't matter. Okay, doesn't matter. And this is a capacitor Cornell W8 Beaver. What's the Beaver part? And then this one. Soldering looks. That's probably okay. Well, yeah, no, this one here doesn't look like it's actually soldered properly. It looks like it's just wiggling inside this ball of solder. Okay, anything else in here that somebody has done something with? It looks like they just went after the filter capacitors. Somebody wrote something there. Here's the dial string, what's left of it. Definitely caught on something. Okay, so we have a lot of wax capacitors here, there's one here, there. This looks like it might be a replacement. This could be a replacement also. Yeah, this has got some white tubing on it, a clear plastic tubing. That's not from. So this is a replacement. Why do you replace this one? So sometimes there'll be a capacitor associated with the grid on the output tube, and that capacitor is critical, and it's probably this one. Looks like a 0.01, which is kind of the right size. So probably the person who came in here knew a fair bit about how to deal with these radios, recognized the radio was humming, and obviously, and changed the filtering capacitors, and then went after the blocking capacitor to the grid of the output tube. That's my guess. So whoever did it knew what they were doing. Why 2 pointers? Why? Why? Where'd the speaker go? Who took that? We don't know. Okay, some more fragile parts here and there. Here comes Wally again. We're just passing through, right? We're right on the keyboard. Okay, we're still, hello, still working here. We just blew right through. So what's going through my mind is, should we try to power this thing up? This is really challenging. Don't know the speaker's correct. There's a lot of problems. So I'm going to stop, drink some coffee, and ponder my next move with this. Yeah, I got to think about this a little bit. I'm not sure it makes sense to try to start this thing up. So wow, it looks like there's sunshine beaming in here. What's happening? Don't know why it looks like I'm under, like a nuclear bomb has gone off somewhere here. Let's see if I can fix it with this. We'll see. That's a little better. There we go. Confused camera. Okay, well, now, don't step on the keyboard, cat. If I'm going to make this guy work, I'm not going to do it by plugging it in the wall. There's a little too much going on with the power supply with all these capacitors and whatnot. I do have a bench power supply. It's this box up here. It'll produce the voltages necessary and the current necessary to run the heaters and operate the and supply the B+. I'm getting distracted by my cat here. What are you after? What are you after? He's after anything and everything. Okay, so that involves a number of knowing a number of things about the radio I don't know right now. Maybe I can just figure them out by looking at it. So for instance, where would I put, if I'm going to supply B+, where would I put it in here? So an obvious spot is right on the top of this big capacitor, or this one, or this one. Are they all going to the same place? So this capacitor, turns out I was right, not soldered in. It just popped right out. This one, the negative side of this one goes here. That's the negative side of this one. Looks like it's not to the chassis, which is a very important thing to realize. This one's down to the chassis here. One of these, this one's going over to the rectifier tube. One of these could be a bypass capacitor for the output tube cathode resistor. 16, this is a 16, this is probably the same thing here. 10, this is a 10, this is a 16, and this one is a what? It's just out of sight here. I just can't quite see it. Let's see. Where are you? I'm looking for a little mirror I have. Oh. disappeared for now. Here it is. Here it is. I see one. I couldn't see it. Now let's take a look. This one looks like a 20. I think that says 20. So these capacitors are likely to be in fairly good shape because they're relatively new. The question is, if I stick B plus on here, am I sticking B plus into the radio generally? Let's see, the positive wire here goes to this terminal. You can see red wires coming off of it. That's usually a strong sign that this is the B plus, a B plus point. So I could put my B plus right into this. And what would happen? I don't know exactly. So, okay, so there's a B plus possibility. Now, the heaters, all I got to do is pick off any, gotta think for a minute. The heaters are hooked up to the transformer. The transformer will still be hooked up. If I hook up a supply, I'll be supplying into the transformer too. Why can't I use the existing transformer to run the heaters and just avoid the transformer's B plus action? Okay, because I'm going to replace the B plus with my own source. What would that involve? You know, I think we better get a schematic on this before I go too far and I'm just wrong. So this one is, I haven't even looked at what it is. This is a Philco. Looks like 53A. Philco 53A. Okay, let's see if I can find a schematic to take a peek at. Okay, I found the service manual for the radio, and this is on Pacific TV. Pacific TV is an outfit on the west coast of Canada, and they have a great supply of Canadian schematics for Canadian built radios like this one. Okay, so it just talks a bit about the radio and a few things. All this matches the radio itself. Here's the list of tubes: 80, 6F6, 6K5, 6J5, 78E, 6J8. So these are older tubes that are much more rare than tubes that came just after this. So these are the tubes with grid caps on them. These all have caps. 3 of them have caps. 78E doesn't have a cap. So later, like the 6K5 became the 6SK5, and the S meant single-ended, and they got rid of the cap that's on the top of this tube. So that kind of dates the radio as being, I'd say mid 30s. I would say mid 1930s. Maybe it even says on here somewhere. Let's say the very top. No. Okay, and just a bunch of instructions we don't need to go through right now. Here's a schematic diagram. We're going to study this part layout chart, which is very helpful. Where's those big filter capacitors? Here they are. These are, what are these? These are probably them here. 38 and 39. 38 electrolytic condenser 10, electrolytic condenser 20. Speaker field, it's important to know that. There's a field coil. We'll see that on the schematic though. And what's down here? Aligning RF and IF compensators. Very good. Excellent. An excellent service manual. Thank you, Philco and the engineers there, for doing this. It's very nice. Let's look at the schematic now. Zoom in a little bit. So what we're interested in right now is generally getting familiar with the schematic, but also understanding the power supply issues and trying to power this up. So something that caught my eye right away is this arrangement. The plate is set to ground. So I believe what's going on here is the plate is out of the picture, and the grid here is acting as the plate, and this is the diode, and the plate, you just got rid of it electrically. And something else interesting over here, 2 plates. Here they show them right side by side. You see this one? Can you tell there's a little grid drawn here? It's kind of a crummy drawing. So
I think there's one tube here and one going up this way. And of course, electrons don't operate like this at all in these tubes. This is just a pictorial representation. There's nothing like this going on in the tube. But the idea here is this single grid here is supplying both this side of the tube and this side. So this is the oscillator side, using a triode to generate the oscillation, and then the oscillating grid is just extended into the electron flow from the other side of the tube. And that's how you mix the two signals together. Okay. This will kind of break my brain looking at this in detail right now, but suffice it to say, just lots of band switching going on here. Some notes we should read. Switches shown from rear of chassis. Okay, we don't need to know that yet. Direction of rotation from rear of wave switch. Okay. What is this exactly? There's another switch here, A7. Another one here. So they're showing these switches kind of odd. Odd way to show them. It's okay though. Generally this is a lovely schematic here. So the rest of the radio's quite normal. So we've got two IFs. One of them's up above. This one they've got in a can. So this is the one we saw up above, and this must just be the coil underneath. There's one coil underneath. And the audio is picked off right in here. And what about AAVC is picked off this way. There's the dot there. Oh, there's a little unusual thing going on here. And this is the headphone output. So this looks like a... I don't know what they're doing here. I don't know what they're doing. That's a suppressor grid. Usually it's just grounded. I don't know. Often it's just tied right back to the cathode. Don't know, doing something. Oh, these engineers. Clever men. I suppose there was a few women involved. I don't really know. I don't know of any in the early days. I have a book written in 1923, and it's the history of the development of electric of radio. In 1923, somebody wrote a history book. We think, wait a minute, isn't the history just starting in 1923? Kinda. Okay, let's look down here at the power supply now. So here we got your classic pi filter with the field speaker. Oh, cat on the keyboard. Oh. Okay, are we still? Hello, we're still on here. Hopefully. I better check. I have to check. Yeah. Okay. Everything's okay. He walks on the keyboard. I don't know what he doesn't tell me what keys he's touching. So here we have this is the part that I would want to remain operating. I want to kill all this. One easy way is to pull this tube out. Pull this tube out. This wire goes nowhere. This wire goes nowhere. So this is doing nothing if I pull this tube out. It'll also cut off the circuit here, the heater. So only thing that would be operating in a sense would be this. Pull this tube out, only this continues to operate. Fire up the power supply here in the normal way. Break this connection. Do I have to even break it? Would I even have to break it? Because from here, so this is missing right now. So we have to figure out which one this is. Well, we got to get on this one. No use putting power into this side. It's going nowhere. So I got to put it into this one. Number 39. I mean, he's changed them in the radio, so I don't know if we can really... Well, he may have put them in exactly the same physical position. So let's look at that chart again. Where is it here? And this says 39, and look, it's bigger. 39. It's right in behind here. Yeah, that's that yellow one, the bigger one. So this is probably the one to fire up. I probably just put the power into the end here. And the result of that will be B plus extending from here. Can't go this way. This is missing. So it's going to extend here and into the radio in the normal way. So I have both the heaters going and B plus applied. And that's all it really needs. I've cut these lights off. So I couldn't really get... What am know how to finish that sentence. I'm not going to get more out of looking at this. Let's just look at these notes again. Tuning condenser. Small section, large section. Is that right? Small section, large section. They look identical to me. Well, I don't understand what they're talking about there. Large and small. Tuning condenser. So it's here. And what is showing it here? So the dotted line indicates all these things are mechanically connected. So turn one, turn them all. Here? What's this? What's this pointing at? What is going? And what's this pointing at? It just bends out in space here with 2 written on it. What is that? 1, 2, 3. What are these numbers? 1, 2, 3. 28. Parts numbers. So this is a part number 1. This is a what? What is this? Part number 2? What is it? I don't know. I don't know. But the guy's ruler slipped when he was drawing the dotted line. So here we see this switch is this switch. No. I take that back. I take that back. This is the tone control here. The switch is on the tone control. And this is a classic, there's a word for it, I can't remember, the kind of tone control that simply drops the treble. And they're just kind of showing this in a weird way. They put a dotted line here. You know what? The guy doesn't know what to do with dotted lines. That must be the problem here. Yeah, this switch is on the back of this volume control. But he's kind of showing it in a way as if these things are mechanically connected. Well, of course they're not. Well, they are actually, aren't they? They're the same knob. Okay, he's smarter than me. I wonder if he left his name on here. Still don't know what this is all about. Doesn't really matter. I'm just overly curious at this stuff. So, you know, what I'm thinking is there's hints in here, and it's up to you to find them. You know, written on the page here, you got to look for them. Shortwave, broadcast, oscillator. Here's some hint. Oh, thank you. Here is the oh, thank God I spotted this. This is the string diagram. What are my cats doing? They're just okay. It shows exactly how to do this. Lovely. There's the pointer. Pointer at low frequency end of dial gang closed. Pointer at low frequency end of dial gang closed. That's not a very helpful note there. We have the parts list, parts layout. Okay, so I think I can do this. I am going to stop for a bit and drink a little coffee, and then we're going to attempt to make this thing work. While I was drinking my coffee, I realized I didn't give too much consideration to the speaker situation. So I'm going to look back at the schematic again. And down here. And let's look at what's going on. So this is not the speaker I have. This is the speaker that should be with this radio. It's gone. But I think the one I have is pretty much the same in how it's arranged. So here we see the they're not, so the field coil is shown down here. So this is the output transformer. Now the radio itself does not, I'm looking to see right now, it does not have an output transformer, so no surprise, it must have been on the speaker, which is normal. The speaker I have has its own output transformer, so I need to hook up this line through the output transformer primary here, and then that's all I got to do. I got to figure out which of the 3 wires that are coming out of the cable. They don't show the cable here. Which of the 3 wires, which 2 are the ones I want? And if I get the wrong one, what happens? If I get the wrong one, I'm hooking up here. I think this is one wire. This is another wire shared. And then the 3rd wire must be this wire here, all going to a plug. Okay, I think I got it under control.
Okay, let's get the speaker up here. I hadn't talked about the weather today. Do you know why? Because it's snowing outside and we have weather alerts here for blowing snow, freezing rain. Not good. Fortunately, about probably 40% of the bulk of the snow has come off my roof now, so it's not so heavy with snow. Okay, here we are. So we have the field coil. You can see a wire right here. This wire right here is the hum coil wire. No doubt down in here are the voice coil wires. Wait a minute here, what is going on? So this is a voice coil wire here. This is another one here. Oh, there's an awful lot of dust up in there. Wow. Whoa, 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 whoa. Not stable. So can we just look at this and figure out which wire goes where? I think so. I think we'd be pretty sure this wire goes here. But this is probably the shared one. I don't know though. Could it be the shared one? How would the shared one work? The shared one would have two wires coming up. Here they are. Two wires. Either to here or here. These two wires, I got this right? I don't have this right. No. These two wires are the field coil wires. They probably go like this. Bit of guesswork. This one is going to the primary here, and it's going here. So this is the primary. So one of these two is the grounding, or the common wire. I got to figure out which one of those it is. Maybe by looking at the radio now. Okay, so here's the. Does this plug actually just plug right in there? I think it will. You know, there's a chance this will work just the way it is. I don't even have to think about this very hard. Should I just gamble? See what happens? What bad thing could happen? B plus across the voice coil. that would be a bad thing. So the wires are color coded, but just like me, they've turned a little off as they gotten older. I can certainly do the ohm thing and trace them around. It's pretty easy to see where they're going. Let's see. This one I can tell already. This one is going to the ground. So we can figure out which one's the ground here. The ground, common one. Let's try it. So I'll put this on resistance here. And then the one I said was going, not really going to ground. It's going to the negative side of this terminal, of this capacitor. Let's take a guess. It's this one. Okay, and I put the meter in front of it. Put it there. Put it there. There we go. Okay. Well, is it this wire? Would look like it. That's not the one I was talking about. So is it this wire? This is B plus here. I can see it because it's this terminal with the red wires and coming from here. So that's B plus going down there. So that's a field coil, connecting to the field coil. The other two are the audio coils. There's no real polarity to it, as far as I know. So, okay. Now, getting back to what I'm doing. So now I know that. Getting back to what I'm doing, I never left. I know this is B plus. These are the two that are carrying the audio. One is going to what looks like a ground spot. I'm not sure what's going on. No, this is the negative side of the back of this capacitor. I have to study the schematic more to really understand this, perhaps. So we want to go up here and say, well, are you this one? How about you? You have, based on elimination, you must be this one. Okay, so the B plus is going into the left eye. The two eyes and a mouth. The left eye is getting his left eye, not the one on the left. This might not be the best way to do this. His left eye. Don't go in his left eye. So these two are the ones that I want to attach to the output transformer of this. His right eye and his mouth. Okay, so wait a minute. Turn this thing. Oh my God, my phone's ringing. Okay, now that I'm thoroughly distracted by the phone call, what was I doing here? I was trying to sort out, could I just plug this guy in here and as luck would have it, it'll work. So, and I forgot almost everything. So it was the guy's right eye. It's this one and this one, which is this one and this one, which appears to be this one and this one. But that's not what I got here, is it? What did I get here? Yeah, I did. I got this and this. You know what? This can be plugged right in. Really? You can just plug this in and it's going to work out? Is it? Well, I think it would. Well, I shouldn't have plugged it in now. It's kind of awkward what I've done here. Okay, so I'm going to stop for a minute and get this arranged so we can do the next step, which is to actually apply power to the radio, and I have to put a power cord on it. I have to consider how much time I put in here today. Maybe I reached the end already today. Well, let me check all this out. Okay, I think I'm just about there now. Let's pull out the rectifier tube before I forget to do that. That would be a bad thing if I forgot to do that. Okay, that is definitely the rectifier tube, not the wrong one. So, the idea here is power up, plugging this into my controlled box here. This is the first time you watch my videos here. There's a lot that I'm not explaining because most people have watched lots of my videos and they've heard me explain these things many times, but I'm going to need to do it again. This is not going straight to a regular outlet. This is going through a transformer on the way to the outlet. You can see a box here that has such a transformer in it. There's another one behind it for some dumb reason. I've got two of them going. So the point is, this is not a regular outlet. It's an isolation transformer. Secondly, I can direct the power when it's coming, to this outlet and therefore into the project through these light bulbs if I wish to. These are incandescent light bulbs with a filament in them. This one's loose. This one's on. This is a low wattage, fairly low wattage bulb, so it puts a large restriction to how much power can come over. So the idea is, when you're first turning something like this on, maybe it has a short circuit in it. You'd rather not, blow your fuse or your circuit breaker in your house. So you use these lights. This is called a dim bulb system, I guess. And you can look that up on the internet to find more about it. So it doesn't get any simpler, yet I find it really advantageous. When I turn the power on, the light's going to come on a little bit. If it comes on really bright, then I know that this thing's drawing a lot of power. If it comes on totally bright, I know there's a short in here. Meanwhile, all that's going to happen is the light bulb will have come on. There's nothing. And I would know right away because the light bulb's right here. It's going to blast me in the face. I'm going to know right away that something's going wrong. So I really like the dim bulb thing. Much better than just watching a meter or something of that sort. Now I can also control the voltage here with this knob. I can turn it up and down, so we are going to turn it down to start with. Then I have a switch panel here. I hear a cat coming too. So this switch panel controls whether the power will go through these lights or straight to here. So if I throw this down, first this is on off, so it's off. If I throw this down, power goes through the lights, so you can hear the sound of this switch. Sometimes you can't see me do it. You'll hear the sound of it going. Power will go through this way. If everything looks good and I care to, I can just do this, and then it's getting 115 volts or whatever I have this set to. So the idea here is to start this thing up slowly in case I've done something wrong, or there is something wrong with it. Wait, what are you up to down there? Yeah. I thought they went to sleep because it got so very quiet in my house suddenly. Okay. So also now, AC going in here through the switch. I decided to run it through the switch. I'm using this temporary clip, which isn't the best way to do it, but good enough for me. This capacitor can stay out for now. I don't even know what it's doing exactly. So this is going to be the B plus here. This cable is plugged into my power supply up there, and I'll be able to ramp up the voltage slowly up to an appropriate B plus, which would be what for this radio? Probably 100 volts minimum to make it work, maybe more, 150 volts, and probably typically running at 250 volts, maybe even a bit higher, I'm not sure. So we need to attach this one side to the chassis, I am sure. We can pretty much go anywhere where it gets a good bite. And the other side on the top of this capacitor. That's my plan. What to expect. So first thing we'll do is we'll simply try to heat the tubes up by energizing the power supply, the power transformer, and making sure nothing else happens in this radio. That's number one. Number two is with the heaters off to apply high voltage B plus to the radio. Heaters off so tubes don't conduct, and then we look at what kind of current draw is happening. If the current draw is high, then something's wrong with the radio. If there's no current draw, based on, I have meters up here, based on the current meter, then we're good to go. Apply heat the tubes up, whole set starts working. Issue becomes then, what about this? What mistakes could I have made here that would damage this? And that would be, you know what, it'd be a little tough. The voice coil, which is the fragile part, is protected by the output transformer. So the worst thing I could have done here is short circuit through the output transformer. If that's the case, I'm going to discover that during my high voltage ramp up and observing the current. So I think everything's good. I think I got all the off ramps I need here, including my shop door is open. Let me clear the doorway here in case I need to run for it. So flash glasses, no, I don't think I need that. Ear protection. Okay, order of things. Heat the tubes first. Okay, here we go. How do I know the tubes got hot? We'll be able to see these, especially if I do this. Oh, this was way too bright. We should be able to see them. I may have to make it a little bit darker too, but. And we can control the voltage a little bit, so we're going to do that. I'm going to turn it down. We do have the dim bulbs in the circuit, so here we go. Next click you hear is power applied. So my first observation is the light did not come on at all. Oh, because the switch is off. So, okay, we got this set to 80 volts. Not 800, 80. Okay, so we're going to cut the power. We're going to turn the switch on. This time, you should watch this dim bulb should come on. And it may come on very bright at first because all these heaters in these tubes are all cold and they're going to draw a fair current for just a couple seconds. So the light's going to come. What I expect is, that's what I should say, the light will come on quite bright and then it will go down about the same rate at which tubes heat up. So about 15 seconds the light should go down, probably stay on a bit. Okay, this is the moment of truth here. I don't think there's any slower way to do it. The lights come on, the light is getting dimmer. It's very good. That means whatever is drawing the power is warming up. It should only be tube heaters. Excellent. So it's going down, down, down. Only 50 volts reaching the radio right now. You can see too, as the tubes heat up and draw less current, the voltage goes up. Because the less current is causing a smaller voltage drop in that light back there. You barely see the filament now. So I'm going to screw the other light in. maintain the lights. I'm going to screw the other light in. This will jump up to like 100. Well, it's going to jump up. I don't know where. Let's see. 75. Okay, I'm going to be quiet for a moment and hear if anything's happening. Couldn't even hear a cat. Okay, we're going to raise it up now until this thing says 100 volts or so. Of course, I'm not going to hear anything out of the speaker because there's no high voltage in the radio. I'm still running it through these light bulbs, and these light bulbs are dropping the voltage a little bit, so it's taking a while. I'm up at 106 now. That's enough to operate the radio. We can now observe the tubes. We'll douse the lights here. I have to unplug them. Yeah. You can't really tell what's going on, but I can see 1, 2, 3, 4, 5 tubes. Isn't there 6 in this radio? I thought there were 6. Oh yeah, there's only 5 because I pulled one out. Okay, that's great. They're all lit. Now, just give me a second here. I have to figure out how to get some light on in here again. Whoops. There, that's good. The light. Yeah, I'm not gonna. I'll just leave it like this. We'll just use my little shop bench lights here for now. Yeah, you can see what radio this is really intended for, assuming this is right. KM67. B plus is next. So the thinking was I would do this with the tubes off. So I'm going to turn the tubes off. Well, you have to let them cool down, because as long as they're hot, they're going to conduct. Okay, so the next thing now is to get this guy ready. So we'll flip this on to standby. Make sure the B plus is set to nothing. The meters on this are very inaccurate. I don't know if you can see, there's a red line up here, which is the red line. So if this meter rises up to this point, this guy is overdoing it. It's too much for him. This meter shows the voltage. It's very inaccurate, but at least you can see that there's something going on, going up and down. What I expect will happen is we will hear something out of the speaker, clicks, hiss, noise, something like that. Not much more than that. I wouldn't. I haven't hooked up an antenna or done any of that kind of stuff yet. Oh, I haven't done that. Let's do this. Okay, so tubes are cold now, so we can apply the high voltage, and we'll see what happens. Here we go. Just flip this over. The voltage is 0. The meter doesn't say 0. But I'm not going to raise the voltage up, and we're going to watch this meter here. Now you have some trouble seeing it, but I'm looking at it very carefully. What we should see is every time I crank up the voltage, there should be a capacitor charge running in and then fading out as the capacitor charges up. So the meter should charge up like this. Only it could be very, very small movement. Let's see what happens. So you probably couldn't see it, but it did exactly what I said. It went up and came right down again. Okay, where are we on the? According to this meter, we're 100 volts, no current, and we're like 200 volts, and the current is dropping down to, again, tiny. The scale on this, that would be about 1 milliamp, something in that order, very, very small. So it's passed the test. There's no shorts in the B plus system of the radio. Next test is the whole radio operating. So the B plus is off, and we're going to turn on the heaters again. Here we go, through the dim bulbs, just for a moment. Oh, I did it through the dim bulbs the whole time last time, didn't I? So I'll leave the bulbs in just in case something happens. Bearing in mind this capacitor is not connected here, it's just, I don't know what it is. Don't worry about it right now. I mean, how important can a big capacitor be? Okay, so we now have the tubes heated up, speakers plugged in. We're about to raise the B plus. We got to listen very carefully to what happens in this speaker. What bad thing could happen? I raise the B plus, and the B plus sees a short, and the short will be on the meter up above, which I'll be watching. You should watch for smoke coming out of any of this stuff. You watch for the smoke, I'll watch for the flames. Here we go. I will read out where we're at voltage wise. So we're going up. We're going up. Current seems just fine. 50 volts of B plus. We're going up. 100 volts of B plus. Can we hear anything? I can hear something humming, but it's, who knows what it is. Something in my shop is humming a bit. It's probably the power supply up here. So we're now drawing a fair current, 25 milliamps. Well, that shows these tubes are conducting. We're still not hearing anything at all. Turn the volume up, Jim. Turn the volume up. Oh! Bingo! Okay, a little dirt in the volume control here. Oh no, not a cat. You coming up here now? This is not a good time to be up here. Okay, we're going to clean that control right now. If you step on my keyboard, am I still going? Volume control, I'm spraying some WD-40 right into it. Yes, WD-40. Go ahead. Shoot me if you want. Ooh, that's a lot. Quiet down, man. Did I not spray it right in? Usually this quiets them right down, but don't worry about it. It's a little noisy still, but it seems to be working fine. Turn it up. Full blast. What are you doing here, cat? Here, chase this. Here, go, 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 go. There he goes. Okay, he's out of my hair now. So, what will we try now to find out if things are working? We could work the band switch. We could put an antenna on it. I could grab the antenna. Which one is the antenna? A little hard to say for sure. Well, B plus is running at 100 volts, but we're not hearing anything. Let's take it up a little higher. The push buttons, I'm going to make sure, I think there's a phono input, but there's no phono switch. The dial button, I've got to push that dial button. Which one was it? The dial button. Which one was the dial button? The dial button was the one on the far right-hand side. Okay, so I'm going to push the dial button, but I'm going to shut it off when I do it. That's not really shutting it off, is it? That's shutting half of it off. Let me knock the B plus off. Ooh, did you hear a little, hear a little squeak come out of it? So we want to push make sure the dial button is depressed. It is now. And the band switch, we would want it to be where? Where would we want it? Where's my flashlight? It's very dark in my shop right now. Okay, where do we want that to go? So broadcast is all the way to the right. All the way counterclockwise. All the way counterclockwise. We want it on an AM because that's the most likely place we're going to pick stuff up. I need a little tool here. All the way this way. It is. Okay, so it's on broadcast. It's on broadcast. Okay. You know what? We're going to hook an antenna up. Well, I'm going to stop for a minute and just go get the antenna. Go get an antenna. Okay, I'm ready now with an antenna. I have an outdoor antenna. It's a mini whip type antenna, and a long lead-in leads to these guys here. Assuming I've got everything switched on properly. I may not. There we are. Okay, So we've got two wires coming out. One is the ground and one is not. And which is which? Which is which? Which is which? So I don't think I'm going to be able to tell here. Still working in the dark. Looks brighter on camera than it really is. So, oh, I can see clearly which one's. Clearly, this black one is the ground. So I'm going to hook up a real, grounded item here for the first time. So once you hook up one grounded item, like any of these pieces of equipment and stuff like that, then the isolation is defeated from the isolation transformer. But it will not make a difference because the two grounds I have, one from the high voltage supply and the one from my antenna, are the same ground. Everything's the same. So we're good. We have an antenna on there. We'll put the B plus back on. B plus is on, and crank it up. So we got about 50 milliamps flowing through the tubes now. Don't hear a thing on the speaker. Volume. That's a tone. No, it isn't. That's the volume. That's the volume. Oh, this is the tone, Jeff. The tone has the switch on it. So, well, that sounds like a radio. Whoop. Okay, let's tune the radio. Come on, baby. Come on, you can do it. Not hearing anything. Okay, it's possible I don't have the antenna connected correctly. Oh, definitely. It's definitely hearing. It's hearing the antenna for sure. Well, that's the end of the test. That's enough right there. You don't have to hear a station at this point. Good. Okay, that's enough. Power down. No use taking any unnecessary gambles here. Power off. Very good. So what has happened here is I've managed to prove to myself that this radio is capable of working with just minor repairs, capacitors and stuff like that. It appears to actually be working as it is. We didn't test the internal power supply, but what is it? It's just a transformer and some capacitors. We didn't get a chance to test the field coil on the speaker, but I'm almost certainly just plugging it in is going to work properly. So very, very good. Very positive about making this guy work. Got to put a string on it. Who knows what else is in store down the road, but she's not dead yet. So thanks a lot for watching, and we'll carry on tomorrow and start. What will we do tomorrow? I don't know. Come in here and have some more fun. That's the main thing. Have a great day. See ya.